Hello everybody, my name is Yuri Bendel. I am Vice President of Greatech company responsible for Simulate business. Welcome in Prague. Prague is nice city, actually with not so many tourists due to COVID situation. But the COVID restrictions allow us to organize nice event, Greatech Advanced Design Award ceremony today. We received more than 50 very interesting projects and I am curious who will win today. I am sure that in the studio is everything ready for live broadcast, then let's go to the studio.
Good afternoon and a warm welcome to our first Greatech Advanced Design Award ceremony, live from Prague. My name is Craig Mallard, the Simulate Specialist from Greatech UK. I'm joined here today by Francis Guillaume, founder of and president of the Greatech Group, and Joseph Pace, the Chief Product Officer. The Advanced Design Award ceremony is a celebration, an international contest organised by Greatech, dedicated to structural engineers and design offices. The aim of the competition was threefold. Greatech wanted to determine the best practice of advanced design used in timber, steel and concrete design projects in 2021. We also wanted to recognise the great skills, imagination and hard work you, our customers, have put into your projects using advanced design. But lastly, to highlight for new possible customers and users what they're missing out on with advanced design. So for those of you who are not familiar with advanced design, it's Greatech's flagship structural design and analysis solution dedicated to structural and civil engineers operating in the BIM environment, but also part of the Greatech Simulate product family. We are here today to celebrate not only advanced design, but also the Greatech Simulate user community, consisting of many industry professionals, which as of today, we can say is truly global. We have some exciting content to share with you over the next 90 minutes. During today's ceremony, you'll get to know the winners and their projects, which span across many different applications from buildings, including residential homes, hospitals, shopping malls, stadiums, skyscrapers, right up to some more unusual applications, all driven by our customers and their imaginations. Plus, and I'm sure you're intrigued to know what advanced design is and what it has in common with Batman. We would love to have had you all, 500 plus people to attend in a physical event. However, due to the global pandemic, we felt a virtual event was more fitting. Plus, so putting this to one side, we'll be joined by a few special guests later on today. With this in mind, I'd like to pass the mic to Joseph.
Thank you, Craig. Thank you. So, welcome. Thank you for all being here today, and welcome to all remote connected attendees. I can start saying that Advanced Design Award is successful. We started in March this year, and we got many projects submitted across 12 different countries, showing that this award is a real international one. Advanced Design, as Craig said, is our flagship international Simulate product, translated in 12 different languages, and with more than 20 different design codes, including Euro codes with several different appendixes, Canadian codes, American codes, and so on. As the Chief Product Officer of Greatech Group, I'm really proud on seeing our software used on those real projects. I would like to personally thank all participants for their contribution to the success of this award and for being part of the Greatech Simulate community, using advanced design to optimize their structural projects. It was really difficult to rate all those projects, as they are all very interesting, as you will see. So we decided to create two categories. One category is for customers applying advanced design used on real projects, and another category for students who were able to submit any technical subject, not necessarily related to a real project. We got various projects, really different each other, different type of structures, residential buildings, hospitals, industrial frames, skyscrapers with mixed materials, different type of analyses, linear, non-linear analyses, including also design, steel, timber, reinforced concrete design, until the final detailing drawings for some of those projects. All those projects are representative of the wide scope of functionalities and possibilities for the users using advanced design on their daily projects. For being able to rate all those amazing projects, we created a group of 8 jury members, all experts of the construction industry, including Francis Guimard, the founder of Greatech, and myself. Now it's time for me to introduce Francis, so the president of this contest, who will say a word about the jury members and the Greatech group.
Thank you, Joseph. My name is Francis Guimard. I'm French, and I live in Paris. I'm also the founder of Greatech. I founded Greatech in '87. It was 34 years ago. And now I'm the president of the group. You know, Greatech Group is 500 employees and more than 250 engineers. It's really an engineer company. I'm also a structural engineer in the construction field, and I'm specialist in the dynamic load and also in finite element. At the beginning of Greatech, when I started Greatech alone, it was a startup, I developed a structural analysis software named Eiffel. Eiffel was the first version of advanced design. Now it's totally different. It's much more modern and efficient, but it was the beginning. I'm also a professor in an engineer school. I teach finite element, dynamic load, and some other discipline. I'm proud to share this jury. And for Advanced Design Award, we decided to compose an international group of jury members from different countries. France, Poland, Romania, Lebanon, Canada, representing the construction industry and the education. 8 jury members, 2 Greatech members, Joseph and me, and 6 external members, 3 from construction industry and 3 from engineering university. Please, Greg, could you introduce the members?
Thank you, Francis. So today we've got the jury members connected remotely. So first of all, we have Olivier Chapat. Olivier, hi there. Could you introduce yourself?
Yes, thank you. I'm very glad to be with you today. So my name is Olivier Chapat. I'm a French structural engineer with 15 years of experience. Today I run the structural design office of Bouygues Bâtiments Île-de-France, a French construction company. And we use Greatech products for the study of great buildings, such as Philharmonie de Paris, Palais de Justice de Paris, and now the Arena and the Aquatic Center for the Olympic Games in Paris in 2024. And I also teach reinforced concrete at the École des Ponts Paris Tech. Thank you.
Thank you for that introduction, Olivier. Right, so next we have on the line Peter Nazarko. Peter. Hi there, Peter. Could you introduce yourself?
Good afternoon. My name is Piotr Nazarko, and for me it's of course a great honor to be a jury member. Currently, I work as a professor at the Faculty of Civil and Environmental Engineering and Architecture of the Rzeszów University of Technology in Poland. My area of interest is the mechanic and dynamic of structure, as well as computational methods. For several years, I has also been responsible for postgraduate studies in BIM technology. And from that moment, the closer cooperation with the Polish branch of Greatech began. Thank you very much.
Great stuff. Thank you for that, Peter. Now we move on to Rawad Asaf. Welcome.
Good afternoon. I'm glad to be with you today. I'm Rawad Asaf, a structural engineer and a PhD. I have 17 years of experience in civil and structural engineering, where I worked on several multinational and fast-track projects. On the other hand, I have 15 years of experience in academic field as a lecturer for several civil engineering and mechanical courses, and 4 years as the chairman of civil engineering department in CNAM, Liban, in Lebanon.
Great. Thank you, Road, for your introduction there. So next we move on to Rodrigo Correa. Hi.
Good morning, everybody. Glad to be with you. My name is Rodrigo Correa. I am running the structural design office of Eiffage Construction, a French contractor. I'm involved in standardization. I'm the president of the French committee of Eurocode 2, and I am teaching reinforced concrete in an engineering school, the CHEBAP in France. As my colleagues of the jury, I am still used advanced design and Greatech product for our famous projects. So thank you to give us the opportunity to participate in that jury.
Thank you, Rodrigo. Right, next we're going to pass on to Daniel Bitka. Daniel?
Hello, good afternoon.
Hi there.
My name is Daniel Bitka. I'm from Romania, and I'm a structural engineer. I have 20 years experience in design of steel and concrete structures in the field of civil and industrial construction. I'm certified as a technical expert for structures. I'm also a lecturer at Technical University of Civil Engineering in Bucharest, here in Romania, where I teach steel structures and building information modeling. On the last years, together with Greatech Romania, we organized several courses for our students to train advanced design in our university. It was my pleasure to be part of this jury. It was a lot of projects to be judged, very interesting project from all over the world. The selection of the finalists was not easy at all. The project that participated were very interesting, amazing by their complexity. And I want to thank to all the competitors who gave us the opportunity to analyze these projects. Thank you.
Okay, thank you for that, Daniel. And then finally, our last member, apart from Joseph, is Mike Vance, the Innovation Manager at Steelway Building Systems, based out of Canada. So as you can see, Mike.
Yes, good morning, everyone. I have to say that from Canada. And yeah, I'm a design engineer and innovation manager at Steelway Building Systems, and we're a fabricator and a designer of all sorts of weird and wonderful buildings. And it was really fascinating to see the weird and wonderful buildings that were submitted for this competition. And it was a real pleasure to look through those and to work with the other jury members. And I'm excited to hear from the winners themselves today.
Good stuff. Right, thank you, Mike, there. So, as you can tell, there's a lot of wealth of knowledge in our jury members. So, and of course, we have Joseph, our final member. So, over to you, Joseph.
Thank you, Craig. So, a few words about myself. So, I'm Joseph Pais. So, I'm a structural engineer as well, with about 25 years experience in the construction industry. I started at Greatech some years ago in 1997 as junior engineer doing projects for our customers, demos, trainings, technical support. I went through different job positions in the group, including advanced design product manager at the beginning of the product. I can say that I have specified the first versions of advanced design, taking the continuity of Francis. And in my career, I wrote thousands of specifications, pages, with different codes. Now, I'm the chief product officer of the group to drive all Greatech IP products, create, simulate, fabricate, manage. And also in parallel of my job as several jury members, I am also teaching at the CNAM University in Paris. So I'm teaching reinforced concrete and dynamic analysis. Now let me detail a bit the rules we applied to rank the submitted project, because as I told you, it was really difficult to rank all those projects. So, so we finally got very small differences in the final rates. So we had defined those 5 criteria for the assessments process. So the first criteria about the technical level of the design, the detailing, and the calculations. So a technical criteria. The second criteria about the originality and the prestige of the project. And you will see that we got very original projects and prestigious projects. The third criteria was about the attractiveness, the details, the presentation of the projects, how the customer have valued their submitted project. The fourth criteria was the optimal use of advanced design, projects covering the full range of advanced design capabilities. So it was an important criteria for us. And the last one, the story behind the project, you know, all the difficulties, challenges that our customer faced, and the way they solved all those issues. So then, with all those 5 criteria, we have calculated the average scoring for each project from all jury members and agreed all together, including the president of the contest, on the winners. So in total, across the different categories, we have rewarded several prizes, for example, 5,000 euros for the winner. Okay, so now it's time to see the results of this award and go through the top 12 projects with Craig.
So now I'm going to count down from number 12 down and give you some details around some of the projects there. So we start with 12th place. So this is Jiří Kozák from Czech Republic, and this project is about an observatory that's been completely demolished with a minimum amount of remaining building. There's the original structure, only the viewing towers and the astronomical telescopes, part of the bearing walls were preserved. This project is interesting because it uses a combination of different structural elements. So reinforced concrete slabs, steel beams supporting the floors, and then timbers for the purlins. The structural behaviour is also mixed, with long cantilevers on the first floor and flat slabs supported by the columns. The main user benefits seen here by Jiří was to do with the being able to use advanced design to mix several materials to do the FEM calculations and the design within the same 3D model. Next, we move on to 11th place. So Radoslav Duda from MTM Style. This is a reinforced concrete residential building with 48 apartments, 5,700 total square area, the volume of nearly 13,000 metre cubed. The structure is a slab beam system transferred down to the foundation slab with walls and columns. A model was prepared within Autodesk Revit, both for geometry and loads, which were later transferred to Advanced Design for the static analysis. The model prepared consists of almost 40,000 FEM nodes. Concrete elements were exported to Advanced Design modules in order to perform detailed calculations considering the real reinforcement within the structure. Advanced Design was able to integrate with Revit in a streamlined way. It allowed them to handle the big model that you can see before you and integrate that design modules, which allowed the user to create and the customer to go on and do the drawings within the same application. Next, we move on to Project 10, or 10th place, Krzysztof Krajan, who owns his own design studio. So this particular project was a design of a commercial and service building with mixed steel and an RC structure. There's a total area of 12,500 square metres. The roof structure was made of steel lattice purlins stiffened by trapezoidal steel sheets supported on a cantilever beam with RC footings. The geometry and load model were made in Advanced Design and edited throughout the design process. After the structural analysis, the model was exported to Autodesk Advanced Steel for the connection modelling and the shop drawings. The connection itself were then designed within IDEA Statica after exporting it out of Advanced Design. And the finished model consists of over 4,700 linear elements with over 13,000 FEM nodes. So the benefits seen here within this project was the ability to have advanced design at the centre of that workflow with Autodesk Advanced Steel and IDEA Statica Steel Connection Designer. And this integration allowed them to have many hours and days of time saving within the project. So now we move on to 9th place, Jacek Kuznian from KJ Construction, based in Poland. This is quite an interesting project and shows maybe the diversity of advanced design and how it can be used in other applications. And one of my particular favourites, where the crane was used to be able to, or designed to be able to use and move masonry blocks on a construction site. And been able to, some of the benefits they saw, been able to model the members as shell elements. The pin connectors, pins and bolts were modelled by means of rod element and corresponding diameters. Welds were also modelled as shell elements with the appropriate weld thicknesses. For the analysis, the nonlinear analysis and bucketing analysis using a one-sided support were also used. And this construction model is in mass production on a large scale. So the advantages that have been seen during the project was the ease of use from advanced design. The software is flexible enough to model any type of 3D geometry. Such as for this project, a crane was modelled as shell elements. The accuracy of the results and the short time needed to post-process them is also an advantage for the customer. Right, we move on to 8th place. So Arthur Urbananski from Constructor in Poland. So this is a design of a multi-family residential building with services and underground garages. The total area is over 18,000 square metres. The building has 10 above and 2 underground floors. The structure is made up of an RC slab supported by a mix of RC walls and columns. The foundation RC slab is also supported on RC piles. For ease of modelling and advanced design, the structure was divided into three independent models. Separate models for detailed design of floors to check of the wall beam rigidity were also prepared. The results for reinforcement areas were exported to CAD software for shop rebar drawings. Just one of the parts of the model, Part B, consisted of 500 linear elements and 935 planar elements with almost 50,000 FEM nodes. So the user benefits here were the complete 3D modelling and the high-end results that they achieved from advanced design, and of course the good interoperability, which allowed the customer to save a lot of time further down the process. So we move next to place 7, Nabil Bellat from Vinci in France. So this is the design of the Cité Internationale Université de Paris dormitory with 195 rooms, with a total area of nearly 6,500 metres squared. The building has 1 underground and 9 above ground stories. So with this particular project, the model first started with an architecture, which was then transferred through to advanced design, where they refined the elements for the wind loads and section cut modelling. The concrete elements were then designed within the integrated advanced design concrete module. So within the process, they were able to integrate use the Arch French software, allowed them to combine the loads, and then these were utilised within the advanced FEM simulation within advanced design, ultimately saving time. The integration of the design modules were a huge time saving, with the possibility to get design-driven rebar cages and drawings directly from the 3D FEM model. Next, on to 6th place. So David Zamperi from ZD Structure. So this particular project is for a new tower of a flower storage plant. So the total weight of the structure is 180 tonnes. And this also consisted of over 1,000 linear elements and more than 1,500 connections. And the primary model was created in Autodesk Advanced Steel and then exported directly into advanced design. Loads and supports were defined in advanced design, and the structure analysis was performed, including modal and seismic analysis. The optimised model was then synchronised back to Autodesk Advanced Steel, where the connection modelling and the shop drawing could be created. And then this later was exported out to IDIS Statica to be able to do the detailed design of the connections where all of the internal forces that have come through from advanced design were all present. So again, from this project, the ease of use of advanced design, the BIM integration with Autodesk Advanced Steel and IDIS Statica Steel Connection software. So this allowed that streamlined process from start to finish. Right, we move on to fifth place, Ludwig Bellotti, so Elan Engineering. So this is the design of the Management School of Lyon. So this features businesses and services accessible to the public on 4 levels at 30,000 square metres. The project is made of 4 rectangular blocks separated by an indoor street. The building is 40 metres long by 18 metres wide by 15 high, and the features elements in both concrete, steel, using the design engine within advanced design. A seismical analysis was also carried out using RITS method to achieve the 90% modal mass. The conceptual model was initially exported from Autodesk Revit into advanced design. So the benefits for the customer were the advanced analysis and the powerful FEM engine, and the possibility to model multiple materials within one modelling environment. And then the integration with Autodesk Revit was a real time saver and enhanced that real BIM workflow. We next move on to 4th place, so Thibaut Flan. It's from Intexal in France. So this particular project is split into 3 parts. There's the initial part of the parking, which that has the ramps which are supported by cantilever beams, supported by 10 underground columns. The structure is subject to weather variations, and thus a temperature gradient is introduced into the analysis. This part of the project is actually complete and operational. The second part of the project is the actual hospital. So this building is a Category 4 seismic project located in Zone 2 seismic area. The building is shaped in a curved half pyramid with seismical forces taken from a few shear walls, and an elastic soil was defined to match the actual soil behaviour or structure behaviour. And then finally, the third part of the project, the aeration tank. So this project is a huge reinforced concrete structure with a total of 1,200 cubic metres of concrete, and also 173 tonnes of steel. And then the elastic soil was defined to match the actual structural behaviour. And the construction of this part is actually over, however, it's just going through some waterproof testing as we speak. So as part of this process, the customer has seen a complete FEM system with lots of possibilities, which allowed the structural engineer to handle all of those complex situations that they saw during the project. At this point, I'd just like to pause the countdown and introduce a special guest to the studio.
Hello again. So I don't need to introduce our special guest, known by everyone, for sure. Welcome, Batman, on stage. So you have a busy day today?
Yeah. Exactly.
Okay.
As always.
Thank you for being here.
No problem. It's a pleasure.
So I'm sure you are all wondering, what's the link between Batman and advanced design? In fact, as I told you before, we had many different types of projects submitted. Our customers are doing many different projects with advanced design, projects worldwide, building, bridges, and many different projects, but also some more original projects. When going through the different submitted projects, we saw this interesting one submitted by the company SSA, so Superstructure Associates from the UK. So the project was submitted by Derek Mason and Robin Singe. And it's quite interesting project. So it's about modeling figures for the Madame Tussauds museums, so quite well-known museum. One in Florida, in Orlando, and another one in Sydney. And they had 2 models, 3D models for the company FBFX, which is doing costumes for the film industry. So the figures are built from fiberglass 3D models, and the structure of the figures is a steel skeleton composed by different members with welded connections and a steel rod for the cap. So they modeled and calculated those costumes with advanced design. It was a quite interesting simulation because they had to make some nonlinear analysis about the steel rod to hang the cap, to check the welded connections with Idea Statica, and be sure that the figures can take over different type of loads, including, for example, people, hanging on the figure. So it's quite interesting. We see here on the picture the final results, and I really invite you, if you are traveling for holidays, go to the Madame Tussauds Museum in Orlando or the Madame Tussauds Museum in Sydney, and when seeing the Batman figures, you will think about ourselves, about advanced design and this funny project. I would like to thank this company, the SSA company, for applying for this with this original project. We initially didn't plan to have an award for such a category, but seeing this project, we thought it's a good idea. So Craig will come back to you about it. So Batman, I have a question for you.
Of course.
Are you happy with the design of your cap? Is it everything okay? You are flying fast?
Yes, everything is fine. Honestly, I was impressed what my engineers could do with advanced design. So thank you, advanced design team. Thank you, Joseph.
Thank you, Batman. And I hope we will see advanced design in the next movie, okay? So now it's time to switch to the student category.
Well, it was a very difficult, very hard, very strong job to select only one project, one prize, because we received more than 100 projects from our students from 22 engineer schools all over the world, After several discussions, several time we spent for that, we have selected the winner. And the winner is Ali Kashfe and Michael Fahed from Lebanese University. And for their project, they modelize a tower in Dubai. But I can ask them to introduce themselves and to explain the project. Hello? Hello?
Hello, how are you?
I'm okay, and you?
Thank you for the competition, and thank you for the members of the jury for their efforts and time in the assessment process. So we would like to present our project, the MBL Tower in Dubai. If we can put the slides on the screen. Okay. So my name is Ali. I am a graduate from the Lebanese University. I graduated last year, and for now I'm pursuing a postgraduate studies in École Polytechnique de Lille. So,
hello. My name is Michael Fahed. I graduated from the Lebanese University this summer and started a specialized master program Shabab in Czech. Now I live in Paris.
So, dear members, our project consists of a 47-story tower located in Dubai, UAE. It is completed. It serves residential and commercial spaces, and it has a height of 171 meters. So, dear members, the goal of the project is not limited to designing an RC structure only, but it extends to utilizing advanced design through different life cycles to link data and optimize time spent on revisions and modifications. So, next slide, please.
Next one also. Okay. Building information modeling is a new technology that simplifies the design of a building, facilitates many other phases in its life cycle. Advanced design covers the detailed design, the analysis phase, the documentation, and the fabrication. In fact, what advanced design offered and many others did not was the workflow between detailing and modeling. A wall, for example, is exported to BIM designers to define reinforcements and sections. Then the whole model is automatically updated, offering structural engineer freedom to work throughout different life cycle of the project. Next.
Okay, next, please. For the design parameters, in advanced design, unlike other software, setting design parameters was very user-friendly. For example, defining loads, combinations, cracking properties. You can have both crack on either the parts of a member, inertia and connections and releases, and seismic parameters as well. They were all straightforward and very easy to use. Next, please.
We ensured that a 90% mass participation ratio was reached in the X and Y directions. Here, advanced design had the option to automatically apply a scaling factor whenever the dynamic base shear is less than 85% of the static base shear. Another smart feature was the auto-generated reports according to filters. We generated reports for mass participation, story drift, and slab displacement. They were all checked with the provision of the code. Next, please.
Okay, next. So, for the reinforced concrete design, it was from the three-dimensioning, which we did manually using Excel and according to the provisions of the code, we had an idea about what the reinforcement and geometry are going to be. So here, the software imposed the use of many solutions. For example, in vertical elements and walls, he suggested we use stiffeners on the edge of the wall. This seemed very logical because normally walls are subjected to a in-plane and a torsional moment, especially in the core walls. And through the BIM designers like RC models, column models, we can set assumptions like creep, shrinkage, ductility, buckling length, and safety factors. As shown, it is easy to modify the numbering, the spacing, the splicing, and the force of steel. Next, please. We can utilize the section by using a working ratio close to 100%. Advanced design generates interaction curves and bending diagrams, as well as shear forces diagrams, and the drafting documents. So next. Okay. As we can see on the screen, here the shop drawings of the wall can be exported as a PDF file and can be generated as a CAD drawing if you want to add some modifications by yourself. It is as well for the bar bending schedule. It can be exported in PDF or as an Excel. Next, please. Some details about...
Finally, we would like... Oh, continue. Sorry.
So the main elements were beams, walls, columns, piles, and a solid slab. And this was our project.
Finally, we would like to thank our professors in the Lebanese University and the thank Dr. Rawad Assaf for his follow-up and support during our project.
Okay, thank you very much. We were very impressed with your model and your explanation. Thank you. I just have one question, Ali. What are the rules you use for this model in advanced design?
We worked under the provisions of the American codes. There was ACI 318 for the reinforced concrete. There was ASCE 710 for the seismic analysis, and IBC 2012 as well for seismic analysis. It puts limits to the story drift and many other criteria.
Okay, good. Thank you. You will receive this prize, but I cannot give you. You will receive by post. And congratulations again to the members of the jury. Well, now it's time to give the third prize. And I give the speech to Joseph.
Okay, so the third prize of this contest is awarded to the project submitted by Tomasz Kochanski from the company TK in Poland. So the project is about the renovation of the St. Nicholas Church in a city. I'm not able to pronounce the name, sorry. So I don't know if Thomas is connected online.
Yes, I'm still there.
Hello, Thomas. Hello. Thank you for being connected. Thomas, before going in the details of the projects, can you introduce yourself in a few words?
Yes, my name is Tomasz Kochanski. I'm an associated structural engineer. I also work on the Kraków University of Technology. I'm mainly concerned in structural reinforcing of an existing timber belfry structures, but also another types of the structures as masonry. So that would be okay.
Okay, thank you, Thomas. So yeah, speaking about reinforcing existing buildings, let's go a little bit in the details of your project that you submitted. So as I said, so it's about a church from the 16th century. So it's very important to keep our our existing buildings, and so it's about the renovation of a timber structure. So for that, so I suppose that you was asked to work on this renovation because of the really bad shape of such an whole building in timber. So for that, you have created 3 advanced design models. One for the belfry tower with the bells, one for so if you can just come back a little bit, yes, thank you. So one for the middle turret, and one for the arch, the timber arch of the nave. So for sure, the complexity was to identify the zones that were needing to be reinforced, so requiring some Eurocode 5 design checks. You have run also very interesting dynamic analysis on the belfry tower to check the eigen frequencies. So on the next slide, we see the belfry, so the modeling in 3D, modeling all the timber members. Here we see the eigen, one of the eigen modes of the structure. And on the next slide, we can see the time history analysis, where you have calculated with advanced design the eigen frequencies values that were checked by that you have calibrated on-site the results. So it's really interesting. It's a really interesting application. We see some pictures, by the way, some pictures of the zones and the structure that needed to be reinforced. On the next slide, we see the second part of the project, modeling the turret, in 3D with the members, and running again a timber optimization according to Eurocode 5 to be sure that we reinforce at the right place in the structure. And the third one is on the next slide. So we can see the nave, the timber frame on the nave, again modeled in 3D. To optimize, to check where are the peak values that we can see in red on the picture, and be able to reinforce the structure in the best way, and probably in the most economic way as well. So it's a very interesting usage of advanced design. And Thomas, if you're still with us,
yes.
I have a few questions to know a bit more about your project. So I would like to zoom on the belfry tower and on the modal and time history analysis. Seems quite complex and it's a good technical subject, this kind of dynamic analysis. Can you explain us in a few words the biggest challenge you had on this part of the project?
So the biggest challenge for me was to make a proper model of such a structure, including its, let's say, elastic releases in the nodes, which is the complex task, let's say. So I included also in situ dynamic field test identifications, including fast Fourier transformating. So I got the two frequencies, fundamental frequencies of the structure, and in a, we might say, I made a few attempts to such model the structure, mainly using trial and error methods. Yes, so it took several times to get a proper model. So then, if I checked if the identified frequencies were the same as in the model, then I know it's modeled in the proper way. The second thing is that there is no literature. There is nothing to learn about such structures. So for me, that's the most complexity of this project.
Yeah. Okay. Yeah, very interesting. By the way, I forget to mention, but you wrote two technical documents, two theoretical documents, kind of theses on the subjects that are really detailed and very useful documents, I imagine, for further engineers. Another question, so how advanced design helps you to find a solution to face those challenges?
I find advanced design as a powerful engine and accurate tool for such modeling. It also gave me some kind, let's say, simplification of modeling process. Yes? So it's for me it's important to have less time spent on the project and more time to checking if it's okay. So that's the maybe, let's say, fundamental things. Also, by the intuitive OSNAP tools, it was essential for me, those OSNAP tools, to have a process in the proper way, in the correct way. So I won't have any errors in the model. So the OSNAP tools for me works perfectly. And for the, let's say, scientific purpose in fields of the dynamics, advanced design seems as a suitable tools for such tests and such scientific tests. So I think I will try in the future to have more models of such structures. So.
Okay. No, very interesting, Thomas. By the way, you answered to my last question about benefits because you mentioned fast modeling, so having more time to spend on the results, analyzing the model, post-processing the model. So really good. So congrats, Thomas, for this project. Thanks a lot for being an advanced design user and being part of the GREYTEC simulation company. Unfortunately, you are not able to be with us today, so you will receive this award. Here, I think you can see better like that. So you will receive this award by post in the coming days, okay? So again, thank you, Thomas. Thank you very much.
I also
Congrats.
thank technical support of the GREYTEC, including Mr. Kamil Dziedzic, who helped me a lot with this program. So,
okay, glad. Yes, thank you for him. Thank you very much for the team, and again, thanks, congrats. And now it's time to go for the second awarded project. So we continue with the second prize, which is awarded to the project submitted by Yassine Talmi and Olivier Ruhlmann from OTEIS, so a French company. So it's about a multi-complex building called Iconic, located in Nice, in south of France. Thank you, Yassine and Olivier, for joining us physically here in Prague.
Thank you.
Thank you for coming. Congratulations for this second prize. Before speaking about your project, can you introduce yourselves in a few words?
Sure, I'll start. My name is Olivier Ruhlmann. I'm a structural engineer for OTEIS, and I've been a structural engineer for 15 years for OTEIS. OTEIS is a global engineering and consulting firm with about 500 employees all over France. And our motto is go green and digital. And as such, we are very happy to be receiving this award.
Thank you, Olivier.
And my name is Yassine Talmi, and I'm working for OTEIS as a structural engineer for nearly three years now.
Okay. Thank you, Yassine. So now let's go a little bit in the technical details of this project. So the project is called Iconic, as I said. So it's a project drawn by the architect Daniel Liebenskind. I hope I said it well, and designed by OTEIS. So it's a quite amazing shape, as you can see on the pictures, really architectural. So it's quite big with 20,000 square meters for different uses, so commercial zones, an hotel, office spaces, restaurants, and including an auditorium with 200 places. So the architectural identity of this project is quite different, as we can see on the pictures from the other buildings surrounding it in this area. And it's about two concrete cores. So in the next slide, we can see more the 3D models in advanced design. So two concrete cores with a steel frame around, with the facade. So quite complex loading with the train lines close to the building, so a quite technical model with elastic links, many things. And on the next slides, we can see even better the model with a different perspective, you know, having the core concrete walls, the steel structure, the two rafts foundation slabs. And again, on the next one as well, we have a better idea of the complexity of the modeling. So looking to this project, which is really amazing, I have a first question. This advanced design is technically, we had a look on it, quite impressive. You have big size, of course, a lot of technical details, such elastic links, a double raft slab, elastic support. So what was your biggest challenge on this project?
Well, indeed, we faced many challenges, including a high water table, seismic loading with a spectral analysis. We had a very weak soil, which led us to use piles that were about 20 meters long. But I think the biggest challenge of all was that we were right against a railroad. And we had very strict acoustic requirements and vibration control. And that led us to separate the whole infrastructure from the superstructure. So we are totally isolated, so there's no vibrations that can come from the train all the way to the
oh yeah, very impressive.
to the hotel rooms.
Okay. And how advanced design helped you to face those, I imagine, several technical difficulties?
Yes, we were looking for a software. Actually, we use the software already. We've been using it for a long time, but the reason why it was helpful is because it's very user-friendly. It enables us to use to develop a 3D geometry quite easily, and also to incorporate some technicalities such as the elastic links to do spectral analysis quite easily. So it led us to be quite efficient in this task.
Okay, but by the way, speaking about this complex geometry that we can see on the pictures, how did you do? Did you model from scratch? Did you imported the model from a third-party application? How did you do?
No, actually, we started on Revit, and then we imported the envelope on advanced design, and we started modeling the edges, and then we created like this our model step by step, and the whole conception design process took about 4 months. But I'm talking here about the whole process, like including modeling and also like taking into account modification due to like client demands and architect demands also.
Okay, good. So quite interesting application of BIM workflows, yes. And finally, so you mentioned a few of them, but what are the main benefits of using advanced design in such a complex project?
Well, for us, it is important, and like the main benefit is that advanced design allows us to like import and export from Revit. I'm talking about Revit because we work a lot of times with Revit, but also with lots of other softwares. And also, like it allows us to model with different materials, which help us like satisfy the clients. I'm talking here like about economies on the project, so we can choose like the right material according to the project.
Okay, and the Revit model was created by your teams or inside the company, or it was coming from outside?
It was created by, we have a person working on like just Revit models.
Okay, okay, very interesting. So for sure, we see it's a very complete usage of advanced design. It's a very good project showing all the capabilities of advanced design, modeling complex 3D geometries, modeling elastic supports, dynamic analysis, and so on. So really, on behalf of all the jury members, I'm proud to give you this award. And I would like to thank you for applying. Thank you for being advanced design users, quite advanced design users, and being part of our Simulate community. So congrats, and I give you the award.
Thank you very much.
Thank you very much. Thank you. Okay, so now let's move to the special jury prize. So the special jury prize, it's something that we wanted to create to award the best BIM workflow on a construction project. Again, it was very difficult, you know, because we already saw several projects applying BIM workflows, links between Revit and advanced design, or links between advanced design and Idea Statica, but we had to select one. And this special prize is awarded to the project submitted by Davide. From the ZD Strutture company in Italy. Welcome, Davide.
Thank you very much, Joseph.
So thank you for being here physically in Prague, and congratulations for your project.
Thank you.
Before going in the details of this project, can you say a few words about yourself?
Yes, thank you. My name is Davide Zampieri. I'm from Padua, as a town about 30 kilometers from Venice. And,
beautiful city.
Beautiful city.
Yeah.
Okay. And after my studies in University of Padua, I worked as a structural engineer in a steel construction company, and for 14 years. And then, until today, I am a freelance structural consultant. And I have the opportunity in these years to work for civil or industrial construction in steel or concrete, and also for the claddings. And that's all.
Yeah, good. That's good. Okay, so now we can go a bit in the details of these projects. By the way, this project was already, in fact, described by Craig because it was nominated on the 6th position in the top 12 projects. But we finally took it for this BIM Workflow Prize. So it's a steel. So if we can come back just on the previous slide. Yes, thank you. So it's a steel frame. So it's a multiple storage plant with a total weight of 180 tons. What is interesting and corresponding to this price is really the BIM workflow you have used on this project. So starting to model in the advanced steel, so from Autodesk, then exporting the complete 3D geometry using SMLX files to advanced design to complete the model in advanced design, so placing the loads, the supports, running the steel optimization of the steel members. Including not only for static loads, but including also modal and seismic analysis to take into account the seismic effects. And interesting, synchronizing back the internal forces in advanced steel to design the connections. I imagine the 3D connections.
Yes, yes, all 3D connections.
Yeah, so to design the 3D connections with IDEA Statica. So we see that it's a quite complete BIM workflow through 3 different softwares, 3 different editors, because Advanced Steel from Autodesk, Advanced Design from Greatech, IDEA Statica from IDEA. So that's very interesting to see you going through 3 different products on the same project. The project is quite big as well, because we have seen it in the Craig's description. So more than 1,000 linear elements, more than 1,500 connections, just amazing.
Yeah.
So really very good BIM workflow example. Davide, I would like to place you 2 questions to know a bit more about this project. So as I said, it's a really complete and interesting BIM workflow using 3 different softwares. I imagine it's not your first project you are doing with the BIM workflow. Why? What was the key parameter that makes you the decision to apply a BIM workflow? Why you decided to apply a BIM workflow on this project?
Yes, Joseph. No, fortunately, it's not my first project with this workflow, this BIM workflow. I start with little projects, but I choose that way because I manage completely from the concept to the realization of the connections, and I have an optimal management of this.
Okay. Oh, and you have an idea of the time saved on applying this BIM workflow?
I don't have the count, but I imagine that we saved much time because in such a project, in this project, there are many profiles, many closed profiles, not open profiles, and also the direction of the profiles are strange, not orthogonal, one-to-one.
Yes, and all 3D connections, as we said before. Okay, thank you very much, Davide, for all those details. Thank you for applying this project. On behalf of all the jury members, I'm proud to give you this award. So
I'm honored.
Special jury prize. Thanks again for being an advanced design user, a multiple software user, and being part of our Simulate community.
Thank you.
Yes, thank you, and congrats again, Davide. Thank you. So now it's time to discover the final winner of this Advanced Design Award.
Well, it's time now to name the winner and the first prize. It was so difficult to select the first due to the quality of the project. At the end of many discussions and some fights between,
I confirm.
between members of the jury, we have a name for the first prize, Christophe Faury. We are happy because he's here, and it was not easy because you had a lot of trouble with the plane, but thank you to be here. And the project of Christophe Faury was Maison de l'économie créative et de la culture en Nouvelle-Aquitaine in Bordeaux. It's very French name because you are French and you work in France. Could you introduce yourself?
Yes, I'm Christophe Faury. I'm very proud to be today and to represent my design office, Structure Sud-Ouest at Vinci Construction France. I work in my office for 16 years, and I had a lot of opportunity to work about a lot of challenges, a lot of difficulties, and like most engineers, it's the most interesting part for my job.
Okay, thank you very much. Joseph, could you explain the project of Christophe?
Yes, sure, I will try to.
And why we selected this project?
Yes. Thank you, Francis. As you said, it was very difficult to select the winner. But this project that I will call MECA, it's shorter name, is a very impressive one. So it's a singular architecture, composed by two concrete piers with different heights that receive on top an impressive steel frame, a kind of 3D truss, forming a kind of arch. So that's one of the technical specificity of this project. Another one is the facades with a huge surface because it's around 7,800 square meters. And those facades are hanged with special attachment systems in a seismical zone, which has been a subject of two, how can I say, some technical agreements from an official organism in France, the CSTB. So it's also another complexity. And the metal bridge also anchored on the piers with sliding support. So it's a very technical building. Also, the project brings several artistic agencies, working on the acoustic insulation of the independent stations. So it was also an important subject to deal with, and especially, of course, in a seismic area, according to Eurocode 8. So in the next slides, we can see some pictures to have an idea of the shape of the building, the architecture of the project, and the size. So here we see the architecture mock-up on site. On the next slide, we see some views of the 3D advanced design model. So we can have an idea of the size of the model, which is really huge. And on the next one, we have a different point of view where we see very well the 3D steel truss on the top of the construction.
Very good. It's very impressive, this model. I have three questions for you, Christophe. The first is, you modelize, it's a big model. What were the biggest challenge on this project for you?
For this project, there is a lot of challenges. The coordinations between the steel cover and the concrete structure, the seismic analysis, the under pressure analysis, the connection and the creation of a new fixation for the precast concrete on the facade.
Good. Yeah. Did you have issues with the steel cover and the concrete structure for the seismic analysis?
Yes, it's a problem because in generally we use the same models for the steel cover and the structure, the concrete structure. But the cover studied with another design office, and they used another software, and it's a problem to know the behavior real of the comportment.
Yes, the real behavior.
And
okay.
we used a simple model, skiwear model, with only several linear elements with right inertia, right position of mass, and it's more simply to use.
Yes,
But which
in
is
order to prepare the biggest model.
Yes.
But a very smart optimization and
That is good.
simplification of the project, yeah.
My last question, what are the main benefits to use advanced design for you?
We were using GRETEC software a long time since Eiffel software.
Oh, good. Congratulations. Very good.
But there were a lot of evolutions, and now we used advanced design for each project because there is seismic analysis, cracking under pressure, and for all projects used advanced design.
We like your sentence, you know. Now it's time to give you the prize, the first prize. You are the winner, and thank you very much, and congratulations to the members of the jury. Thank you.
Thank you.
Congratulations.
Thank you.
Congratulations.
I give you, well, I think that now it's time to make a conclusion, and Craig, if you can join me.
So that concludes the first ever Advanced Design Award ceremony. As I'm sure you can see from today's ceremony, the quality bar has been set extremely high. It also highlights the fantastic solution that advanced design is when driven by the Simulate community. Congratulations to all of our winners, and thank you to all of the customers that have submitted your projects to this competition. We received many project applications from 12 different countries. Wow. So thank you to all of the contributors to today's session, along with all that are watching today's live ceremony. A big thank you to the GREYTEC team, and more importantly to you, our loyal customers, for helping us make advanced design what it is today, to allow sessions like this to happen. Please join us for further sessions tomorrow and Thursday, where we'll be showing you and showcasing Advanced Design 2022.1, as well as going into some BIM workflow sessions and an RC slab module session, as well as the crane moving load and the cold roll design in the latest version. So that's me done. Over to you, Francis.
Yeah, thank you. Yes, I would like to say to all the engineers in the world who use advanced design, there are more than 5,000 of them. But congratulations too, because you are a lot of people who use every day advanced design. And you know, 5,000 users represent 100,000 construction design per year by the software. And it's more than 2 million projects over the last 10 years. That it's impressive too. It's not the end of the story, because our engineers continue to develop the software to make it more efficient and adapted to each country. Thank you to the candidates who participate in this contest. Believe me, I'm very proud of your participation. And of course, my compliments to the winners. I also thank you, the members of the jury. It was a hard job, but very exciting. Thank you, and bye.
Bye.